Good morning, everybody. It's 10 o'clock. Welcome to the second edition of Winning Days. Today's theme, as you see on the slide here, is part of the supporting the European Union's Green Week and a focus on zero pollution for healthier people and a healthier planet. So we've got about an hour and a half together. And my name's Mark Pattinson. I'll be your moderator for this morning. Hopefully I will say as little as possible because you're going to be all excellent speakers and excellent participants. I've got everything crossed here for you. So we just move on to the next slide, please, Oriane. Before giving you some insights into the agenda, just some very simple housekeeping rules. I think we're all used to a lockdown mode of working. So questions via the chat, so don't hesitate, and we'll use the Q&A sessions to share your questions with the speakers. Obviously, mute your microphone if you're not the speaker concerned, and turn off the camera because that will give you a better broadband and better reception of all the presentations. Next. We've got 3 sessions beyond this simple introduction and some conclusions. The first one, we're very pleased to have latest insight from the European Commission on the policies relating to the zero pollution challenges in the future. You can already see the chat starting to work. The second one, and I think it's just take 2 seconds here. Water Smart Territories is the sort of a smart specialization partnership that's organizing today's event. And we thought it would be useful to shed some light on the work that the working groups have been undertaking, and also give some insights to where some opportunities for SMEs, and it's SMEs who are the main participants to this call today, can interact with the partners that lie behind the Water Smart Territories, and also in the third session, find some concrete solutions to some of the funding, but also cooperation partnership opportunities that are available. And then we'll wrap up with some conclusions. Next. We're going to start now with our first 2 introductory remarks. We'll start first with Francis Bertrand, who's the Managing Director of France Water Team, followed by Marisa Fernandez, who's the Managing Director of ZINA, the water cluster from Aragon. So just one last remark to make sure this works well. We will remind each speaker 1 minute before the end that they now have only 1 minute left. And if everybody keeps broadly to the timetable, you will all earn your coffee break, which I think is at 11:30, so 10 minutes. So that's the target. Everything will work smoothly, and hopefully we will have some good interactions via the chat and via the Q&A session. So, Francis, the floor is yours, and
thanks, Mark.
Good luck.
Thanks.
Thank you.
Just to introduce briefly this event to you once again, and my first word would say thank you to all to attend, and thank to the panelists to spending of their precious time to give words to all of us. 3 items to deal with while introducing this event today. A few words about the winning days. Why the winning days? Clearly, that's a precious outcome of a partnership, a cluster partnership. You've got these partners and these clusters on the slide: the Water Alliance from the Netherlands, ZINA from Spain, and France Water Team from France. Quite logical. Second edition of the winning days today. We started February this year with an event dedicated to Horizon Europe. So if you see the title of this event today, the second edition of the winning days, and the one, you see that we feel free to connect and to speak about different topics. The core element behind this is that as clusters, we need to get benefit to our members who are mainly SMEs, academics, and connecting our members with these items is the core of our mission, and it is at the core of the winning days. So why targeting today the zero pollution target? Well, it's quite simple. This is something which is absolutely mandatory for all of us. So in any cases, in any places we are working, in any organization we are involved in, we need to do something and to tackle this issue seriously. Water Smart Territories, the acronym WST, is a project factory and is another fruit of our partnership. Marisa will explain you what is behind this another one acronym. So I don't want to go too fast and too long on that. And I just want once again to thank you, namely the Green Week, because this event is labelized, has got the label of a Green Week event, and the Blues Project, in which we are involved a bit on a strong moment of time, so to say. No more words on my side. I thank you again to attend this meeting. I'm happy to digitally meet all of you, and I look forward to have this physical transformation again and to meet you physically. Okay, thanks. My words and the microphone to Marizano.
Yeah, thank you, Francis. Over to you, Marisa, now.
Okay, thank you very much, Mark, and good morning, everyone. As Francis said, Water Smart Territories is working as a factory of interregional project. In this moment, as you can see in the slide, we are 22 regions, European regions, that work with the objective to strengthen the innovation capacity beyond water resource efficiency, link problem owners and solution providers, and facilitate new investment based on open innovation infrastructure and new technologies for sustainable water management. 2 years ago was the European Commission approved creating Water Smart Territories, a thematic within the Smart Specialization Platform related to industrial modernization. And Water Smart Territories give a special attention to the cross-sectoral collaboration between regional authorities, clusters, industry, and research organizations in the water and ICT sectors. In this map, you can see who are part of these Water Smart Territories at this moment. In blue, you can see the three leading regions that we are: Friesland from the Netherlands, Central Val de Loire in France, and Aragon in Spain. So we are 22 regions from 14 countries. Oriane, next slide, please. And then how it works, Water Smart Territories. After mapping all the participant regions, assets and projects, Water Smart Territories launched 5 working groups. As you can see, one is for sludge topics, diffuse pollution, micropollutants, digitalization, and circular economy. And the working groups focus on 3 areas: developing contents and improving connections with networks, sharing best practices to boost replicability in the regions, and sharing also strategic information. Today, we'll see 3 examples of these working groups. The ones are related to the topic of the Green Week of this year, zero pollution. So we will focus on how micropollutants, diffuse pollution, and digitalization working group boost the development of these contents and share best practices. So Water Smart Territories wants to contribute to the European Recovery Plan to make Europe greener, more digital, and more resilient. Investing in water infrastructures and water innovation can be a crucial factor in economic and social recovery, as it saw a recent study of the Chamber of Commerce in Spain that established that each direct job on water management generates 2.79 indirect jobs. So today we will know about what smart territories work, and we hope that this is the first step to boost the collaboration in innovative cross-regional projects. So thank you very much, and yeah, we are really looking forward to hear about what today all the panelists are going to present it. Thank you.
Thanks very much, Marisa. That's a good insight to how the working groups are actually delivering concrete solutions for the participants, the regions and the SMEs, the innovation and research actors. So it's a good launch of today's discussions. We're now moving to the keynote presentation today, and it's a great pleasure to have Avelino Gonzalez from the DG Research and Innovation European Commission. He's going to spend 20 minutes with us and updating us on the EU policy developments related to the zero pollution future. So Avelino, the floor is yours. Please turn your microphone and camera on, and we'll remind you 1 minute before the end. Thank you.
Thank you, Mark. Thank you, the organizers, for inviting the Commission to present this quite, overview on what is moving on, basically. So, first, perhaps to introduce myself. So I'm Avelino Gonzalez. I'm working in DG RTD, as you mentioned. So, dealing with research and innovation on the water sector. My talk today is like subdivided in three pieces. From one side, a very quick state of play. So what's happening. Second point would be more about policy developments, more about legislation and what is the direction for this. And the third point, very quick one, is about some funding opportunities, particularly on the research area. And all these mostly focus on water. So I'm not going to span this presentation across all the different environmental sectors. Otherwise, I guess it would be just impossible to fit that. Anyway, so looking to the rest of the program, I will try to be short. I think that you have more important things to discuss today. And with that, if Oriane, if you can move to the next slide, please. What you can see now on the screen is a summary coming from a report. We call it a State and Outlook 2020 report, which is prepared by the Environmental Agency in Copenhagen. It was published in 2020, so it's rather recent data that they put forward. What you can have here is about an overview of the main water-related policies. I'm sure you know all of them, so I'm not going to spend time on that. In the sense that I will come back to that maybe later when I will talk about the policy development. So what the report says, so, they are talking about trends. They are talking about the outlook. So what's the future in the near future? So 2030, and some prospect and policy objectives. So I'm not going to read it again. So, but what's important to keep in mind, so that we have a very nice piece of legislation on the water for water protection, basically, the Water Framework Directive, etc., and all the doctors' directives related to that. But the point here is that we have still diffuse pollution that remains a huge problem in Europe, mostly related, emissions from fertilizers or to the water bodies, or due to the atmospheric deposition or chemicals used as pesticides. All of that, like biocides, etc., including the urban wastewater treatment plants, finally end up in the rivers. And in that report, it says that member states have identified that diffuse pollution is still a significant pressure on the environment, is affecting close to 40% of surface water bodies and 35% of the groundwater bodies. And as you know, once you get the pollution in the groundwater, it's very, very, very difficult to get rid of that. So this is where we are. And the figures that I mentioned, as you can imagine, is like an average. But you have areas in Europe where the problem is, would say, dramatic instead of this 30 or 38 or 35%. Moving now to the next slide, please, Oriane. Because, so this is the one that I just talked about. If you can move to the next one, please. Thank you. So the report that I mentioned contains some key messages. So as I mentioned, and you know, one of the objectives, so the main objective of the Water Framework Directive is reaching a good ecological status in Europe, but it is only 40% that achieve that good ecological status in Europe. So we are far from achieving that that objective. And for sure, there are a number of places like ecosystems in wetlands, widely degraded, and floodplains, even reaching 80 to 90% of the area covered by the floodplains. As I mentioned before, diffuse pollution is still a problem. Water abstraction, because, well, there is always a big link between, there's connection between water availability and water quantity and quality, as I said. So there is still a management issue to cover all the sectors, agriculture, energy production, but also ensure that there is enough water for nature. Climate change, this is a new factor that is affecting already water availability, is affecting extreme events, variability of precipitations. So there is a new factor to consider, and it also can create water quality problems. Apart those related to flood production or drought management. A key message from that report is also about implementation. We know that we are not yet there, so there is still a number of policies, so water-related policies to implement in relation to the current legislation. So this is one of the key objectives for the future. A strong message from that report is also that solutions should be local. I mean, effective solutions should be found at the level of river basin, a scale where solutions for governance should be found, particularly in transboundary catchments. This is something that is well known and recognized, so progress should be done in that respect. They also suggest some solutions, so like nature-based solutions, so natural water retention, buffer strips, playing with smart water pricing, irrigation, precision agriculture. So a number of issues that are of relevance and could have impact. Next slide, please, Oriane. Now I'm moving to this policy development. So I mentioned the Water Framework Directive. We had carry out a fitness check, so a sort of review or evaluation of effectiveness, efficiency, and impact of the policy currently in place. And as such, it was considered as a good piece of policy that is flexible enough to even accommodate new concerns like micropollutants or contaminants or emerging contaminants. So in that respect, that piece of policy is considered robust enough and fit the purpose for the future. Now we have another one, another piece of legislation, which is the Urban Wastewater Treatment Directive, that is currently subject to evaluation, already done, to review, as during the evaluation, the main outstanding issues were detected: the implementation gap that I mentioned before, runoff and stormwater overflows in urban areas particularly, the fact that individual and decentralized systems are not connected to the main water treatment facilities, also for small agglomerations and non-connected dwellings where they are also sort of unconnected sewage systems. So there are still these outstanding issues. They launched very recently, I guess it was in April, when they said, the commission, I mean, it's my colleagues in DG Environment, there is an open consultation, and I invite you to look to that and to reply, because this consultation will be open till the 21st of July. So it's very important for the Commission to get the feedback on that consultation. It's also considering aspects of economical aspect like cost benefit, etc. It's relatively wide consultation. Regarding the what are the issues at stake? I mean, so because we are now exploring a number of topics for developing further this urban wastewater treatment directive. For sure, we have micropollutants in the loop. So we are looking to that. We are looking to technologies, more appropriate technologies for treatment. Also responding to the detected gaps, combined sewer overflows, urban runoff, individual systems are being subject to investigation. What could be done in terms also of energy consumption, industrial wastewater treatment, emissions, greenhouse emissions, sorry. So both, I mean, from consumption, but also from direct emissions during the treatment or collection and treatment. Mercury is in the scope of these studies. The cost benefits of all of the measures that we can consider. There is a strong, a very substantial piece of work dealing with modeling, trying to put all the data there and trying to get, sort of decision support systems enabling to detect the best combinations on and possible options for the future. Regarding sensitive areas, there is a work in progress on that. Governance, extended production responsibility, applying this polluters pay principle. Also looking to the reporting, involvement of citizens. So these are more or less the topics that are considered in the revision of the wastewater treatment directive. The sewage sludge directive is subject now to the evaluation. For sure, is well connected to the previous one, and this is one of the main topics that is subject to assessment. Also, how to the fate of contaminants of emerging concerns, the micropollutants in sewage sludge, risk and prioritization, compare the benefits and efficiency of and the cost effectiveness of recovery or recycling of the sewage sludge. There is a number of activities related to that. For sure, how it could be better connected to the urban wastewater treatment directive in terms of effectiveness and efficiency. And also work dealing with knowledge gaps, where research world has a stake. Technologies and this part. Regarding the bathing water directive, the subject to review currently. I guess the roadmap has been proposed, and there is another piece of legislation which is related to the environmental quality standards for surface and groundwater that is also subject to review. So this is more or less what is moving in this water-related policy. Next slide, please. So you heard probably about the European Green Deal, so I'm not going to stay longer here. I put there a calendar. There is a hyperlink that is linked to the timeline, in the sense that what is the last relevant communication from the Commission is the Zero Pollution Action Plan. You know, it was released 12th of May. It's publicly available, so you can get access to that action plan. And there are a number of targets that I summarize in the slide. They are looking to air quality, water quality, soil quality, ecosystems, transport noise, waste generation. There are a number of targets that are in the annex, the baseline for those targets. If you want to get a look at that, this is now has been delivered by the Commission, and this you will get there like a sort of also calendar for this action plan. So what are the measures that will take place and when it should be delivered? The actions are detailed in the annex. So there is, as usual, you know, we have a communication like 20 some pages plus an annex with a calendar with the time schedule and the actions. So there is apart that in the Green Deal, there are a number of actions that are related to pollution, like biodiversity, circular economy action plan, farm to fork, chemical strategy, etc. So this is not the only one dealing with zero pollution, but it's probably the most relevant because it summarizes a number of issues. There you can also get access to what I mentioned before related to the water policy development. So it's in one package, almost all the measures that are currently ongoing in that direction. So next slide, please. With that, I move to the Horizon Europe, you know, the framework program for research and innovation that is running from 21 till 27. So we are now preparing the first call for proposals, you probably know. And there we have in cluster 6, we have a destination that is a new term in this work program that is called Clean Environment and Zero Pollution. There are a number of topics related to that, and this will continue in the future. So it's what you can see in the slides is mostly for 2021 calls, and in italic is for 2022. For sure, there is, sorry, there is a number of other pollution aspects in other clusters, another destination of cluster 6, like the one, the topic dealing with over packagings and single use of plastics, microplastic pollution, circularity in textiles, electronics, and low risk and socioeconomic aspect of pesticides in agriculture. So there are still a number of elements in the different parts of this cluster related to the zero pollution. And with that, we can move to the next slide, please, again. Because for sure, as you know, in Pillar 2 of Horizon Europe, we have a number of clusters. Cluster 1, there is on health. There is topics on green pharma, where they are looking for less hazardous pharmaceuticals. A topic on chemical risk assessment or antimicrobial resistance. That could be of your interest. In cluster 4, which is about digital industry and space. So there is a topic on industrial and urban symbiosis, or improving circularity in industry, in production, in value chains. Cluster 5 is, well, there is a topic on restoration of natural wetlands, and or topics in related to transport pollution, like brake emissions or tailpipe emissions. Apart that, in the Pillar 2, we have some missions that are relevant, like the one on healthy soil, that is also looking to pollution and quality issues, and for sure the one on oceans and inland water, where they have a number of objectives related to water quality. That we have the European partnerships. We have both, the private public and the public partnerships, and there are a number like 40, I think 49 or 47, I don't remember now. And for sure there are a number of other actions that are more in pillar 1, like more dealing with excellence, or pillar 3 more dealing with innovation and SME support. With that, I am going to the end. Next slide, please, where you will find there are some links if you want to get in touch on more details on these different aspects. And the last one, just to say you, well, thank you for listening me, and wishing you a very, very successful meeting. Thank you, Mark.
Thank you, Avelino.
Back to you.
One quick, I know you've got to rush off. One quick question in the chat came through. You talked about sediment quality. Has the Commission set any particular targets on how sediment quality should be set or achieved?
Sediments is an issue that is not well addressed, if I might confess. In the action plan for the zero pollution, there is an action very I think that will start already in 21, that would be looking to soil contaminated sites and likely also sediments in that direction. So they want to establish and to map a sort of having a European map on a contaminated site and looking for remediation and for issues like that. I'm not sure that it would be legislation moving in that direction. This something. This might be something else, or maybe following up, because the soil is not well addressed in terms of legislation. There is strategies and a number of issues, but there are no legally binding commitments for the time being.
Indeed.
I think I replied to your question.
Okay, perfect. Well, I appreciate that, and I hope don't hesitate to continue using the chat to ask our speakers questions. So, big thank you again, Avelino, for that insight. We'll now move on to our next part of the agenda, where we're going to focus on the working groups. That's what you see on the slide now. The WG means for working group. So as Marisa said in her introduction, we're going to look at 3 of the working groups, and we're going to start now with some insights into the micropollutants, sorry, my French-English translation. And to set the scene, we've got Peter de Jong from WETSUS, who will then prepare the ground for the 2 experts, which I'll introduce shortly. Peter, the floor is yours.
Thank you very much, Mark. And also thanks for Avelino Gonzalez to be with us this morning and to give a wide overview of the current developments in both the policy field and related programs, because of course many of the challenges listed in the policies will also be transferred into key questions for the European Research Program. And as you might know, there's of course the cluster part within Horizon Europe, but there will also be opportunities to work, for instance, in the partnership, which is being developed at the moment, the European Partnership Water for All. And many of the questions and challenges that were stated most likely also can find space in, for instance, the emission on oceans. As you have heard, there's only 40% of the EU waters have good ecological status. Many of the wetlands are degraded, and 80 to 90% of the floodplains are not in normal ecological condition. Part of this, of course, has to do, for instance, with the changed state of the water management, but part also with the economic pressures on these areas, and for sure also pollution plays a role. Part of this pollution will obviously be diffuse pollution and the concentration of, for instance, nutrients, and therefore a change of the ecological landscape. But also gradually more and more micropollutants end up, of course, in the environment. and especially the persistent ones will accumulate over time. These can have very adverse effects, partly within the biomass ecosystem, so accumulation within species that feed upon other species, and then of course the ones at the top can have a lot of these chemicals accumulated in their bodies, and this might be the end for them. At the same time, you can see other adverse effects, such as effects of the pharmaceuticals, resistant bacteria, but also the normal development of the organs and sexual organs of organisms due to some of the pollution that ends up in the water. We will dive into some of these pollutants in this session, and we will see some of the technologies being developed to prevent them, to tackle them, to remove them from wastewaters. I think this is also very much in line with the Zero Pollution Action Plan. Although within the 3 priorities listed for 2030, I didn't see specifically one addressing the micropollutants, but hopefully micropollutants will be addressed in more detail in the Urban Wastewater Treatment Directive that is currently being redrafted, let's say. For those that are logging in today for the first time, please know that this is the second of the winning days. The first edition was organized in January. And we can say that now, since it's become like a tradition, we actually organize one in every season. So the next one will be organized right after the summer break, be it September or October. And then we dive again into these same topics. So if you're present and you're active in a region, please also look at the website of Water Smart Territories, which is listed on this slide below. Have a look if your region is already active, and otherwise reach out and make sure that you connect, because we look forward to collaborate with many regions. And also with regions already active, please have a look if you're already connected to the European Partnership, Water for All, because we hope to see many of the regions already engaged to also become active there. Okay, this is the ground info, the base info about the working group. Now we have invited 2 experts to share with us more insights. The first one is Lucia Hernandez Leal. She works for WETSIS. I can tell you she's a colleague of mine, and she will be addressing the innovative technologies for micropollutants removal, tackling barriers for their application. Please, Lucia, you have the floor.
Thank you very much, Peter. Thank you, everybody, for this opportunity. I guess it goes like that without the video, right, Peter? Or without?
You can activate your video, I think. That would be the idea. Is it possible?
Yeah, I thought so, yeah.
Please.
I guess it would be nice if we can start my presentation so that I can begin. Thank you. I am Lucia Hernandez Leal. I work for WETSIS already since 2005 as a team coordinator, source separated sanitation, and we have done a lot of work on recovery of resources. But when you do that, you also have to look at what the risks are, so at the pollutants, and to produce safe products. So I dedicate a lot of my research time to also to micropollutants, and that's personal care products, but then pharmaceuticals as well, and we some work also on the removal of pesticides. And I've been around to see different technologies tested, and for now I would like to give you an overview of what is actually applied at large scale and what we do at the other spectrum of it, which is the research that we do at WETSIS. Can we go on, please? Peter already gave it away. So micropollutants, actually, when they are not yet micropollutants, they are pretty amazing substances that have increased our lifestyles and our health. To some extent, they have made us stronger and they increased our comfort, but it hasn't come without a price. And that means that when these compounds end up in the environment, they are going to cause some problems. And that doesn't seem right away that that's affecting us, but in fact it is. And that's not for nothing that we have so many initiatives to get them out of the environment. here you see some examples. So the birth control pill can cause fish have not only female, but also not only male, but also female reproductive organs. You see that when fish or other aquatic organisms are exposed to Prozac, they will be less reactive, and they will be more, they will be less reactive to predators because they are just chilling instead of defending themselves. And well, you have many other examples here. You also see vultures affected by diclofenac, that is in a place that shouldn't be. So very easy, you can say stop using everything and we're done, but everybody knows that it's more difficult than that. And so can you please go on? So like in other countries like Switzerland and Germany, the Netherlands has also adopted a strong approach to tackle this problem, and that's called the chain approach, to get medicines out of water. So the focus nationally in the Netherlands has been to medicines, but of course this can be applied to other type of micropollutants, particularly the ones that end up in wastewater. The diffuse sources, as you have mentioned earlier today, they may be trickier. But when you take a chain approach, you can look at the development and authorization, prescription and use, and wastewater sewage treatment. So at different points in the water cycle, the urban water cycle, and also the production of these compounds, you could take action. Peter already said it. We are a water technology institute, so primarily our impact and our main contribution will go, oh, sorry, next click, please. Yeah, it's on this area of the chain approach. So we look for innovative technologies that will make the removal of micropollutants easier from water. Can we go on? So general classification of techniques that can be applied to get rid of these compounds. You can go and oxidate them. That would mean really destroy them by adding ozone or any other compounds, such as a combination of ozone peroxide, ozone ultrasound. You can also do many other combinations like UV with a Fenton reaction, but that would mean that it will be attacking all of the bonds inside molecules and then destroy them. And if you're very lucky, then you're going to completely destroy them and not produce any other toxic compounds. So the most popular and applied here in this category is ozonation. I believe next talk is going to be about other advanced oxidation processes, so I will leave that to our next speaker. You can also decide to use adsorption, and that would be just using some materials such as activated carbon on any other material, say zeolites, or that's gonna absorb these compounds and then remove them from water. That means you are not creating byproducts, but then you have a material that you have to deal with afterwards because it's full of these compounds. And you can also decide to go for physical filtration, so membranes with very small pores that you can retain all of these compounds. The problem is it can be quite costly to press all the water through these filters. So this is the general classification. Of course, you have biological processes. Wastewater in general first goes to biological treatment. And though this is a wonderful first step to treat water, it has been very effective. It also, it falls short removing these compounds. And many of these micropollutants will stick and concentrate in sludge the way they would, as Peter mentioned, also in fat tissue of fish. Next slide, please. In the Netherlands, there has been a study of several technologies at pilot scale. and to give you a good general idea of what they can achieve. So they fall in the previous classification I showed you. So activated sludge is a biological treatment that I told you is usually the first step. So you see that they do okay removing these compounds, and it's anyway, that's the best price of wastewater treatment. So I just put it there as a first comparison. But then you, after that, can decide to either add activated carbon or do a combination of ozone and activated carbon, which is this ozone and GAC. And you can see that then you get a very good removal at a reasonable price and not so high energy consumption. But then you have to watch out for the production of byproducts. When there is bromide in water, you're going to get also bromate formed. And like that, I have several options, of course. You have constructed wetlands that are very popular because they're nice, you have plants, but okay, again, you don't consume a lot of energy, but then you don't have great removal of micropollutants. So there is a lot of range, and it will depend, of course, what's in the water and how much you want to clean it, because that's not always, the motivation is not always clear to go all the way to remove these compounds. Next slide, please. Right now, the planning is in the Netherlands to do large-scale advanced treatment. And the technologies that are actually going to be implemented are ozonation in the red dots that you see, and powder activated carbon. So you can see that these are the robust technologies that everybody is saying, okay, these ones we apply. And although they have the downsides, we know them, so we apply them. So that's good, they work. Next slide, please. However, as I said, you can have byproducts, they are not so cheap in energy, so we look for other possibilities so that we can improve the selection of robust technology that can be applied. At VETSOS, we work on bioremediation. We try to enhance biology to do their work because we saw that this is the cheapest way and the most natural. We try to work without the addition of chemicals, so you can do that with vacuum UV. And you can improve membranes so that they are cheaper. So we work on nanofiltration, and the newest addition is that we have the vortex mixing with plasma oxidation. So I go quickly on an impression of each of them. Next slide.
Yeah, just to remind you, about 1 minute to go, Lucia. All
right, so this is enhanced bioremediation. We add some NOM to motivate bacteria to degrade compounds, and then you have gray groundwater that is completely clean. Next. You can have activated carbon that I mentioned and covered with bacteria so that you improve this technique. Then it's cheaper. Next. You can do advanced oxidation techniques without having to add peroxide. As I mentioned, you can do that if you go to low wavelengths of UV. Next, please. And this is new nanofiltration, so it's a use of a new design of membrane so that you don't need so much pressure to get the water through. And you can apply this on gray water, and you have a nice source-separated sanitation concept. Next. This is a photo of the demonstration we do here in the Netherlands, in Friesland. Next. We also have to keep in mind it's not only about micropollutants nowadays. They always put in the same breath. They say also you have to remove microplastics and antimicrobial resistant bacteria. So once we have to have a good look at all of this table of technologies. Next.
Yeah, we will have to end quickly.
Yes, that's the last slide, yeah. And then you will be able to have another to look critically at this, but also for the removal of microplastics, and antimicrobial resistant bacteria. Thank you very much.
Thank you, Lucia. Thanks for this wonderful overview. Yvonne asked if the presentations will be shared after the event. And yeah, in general, all the presentations from these events are made public after the event. So I think Lucia also won't mind that part. Thank you, Lucia. Maybe there will be questions later. Now we switch to Amit, and I will try to pronounce it right, but I'm sorry if I don't. Amit Bhatnagar from LUT University in Finland. He will deal with the photocatalytic degradation of pharmaceuticals in water to reduce health and environmental effects.
You did a good job, Peter. Thank you very much for introducing me. Yes. So hello, everyone. I am Amit Bhatnagar, working as professor at LUT University in Finland, as Peter has just mentioned. And can we have my slide, next one? Yes. So the title of my talk is Photocatalytic Degradation of Pharmaceuticals in Water to Reduce Health and Environmental Effects. Next, please. So previous speakers have nicely introduced the topic and made my work very easy. And I think you already know by now that the presence of micropollutants in water is of great concern. And pharmaceuticals are of important micropollutants, And in this talk, I will focus on pharmaceuticals and their removal using photocatalytic processes. So it is well recognized that active pharmaceutical ingredients and their metabolites have been contributing to the current contamination of aquatic and terrestrial ecosystems all over the world. More than 600 pharmaceuticals or metabolites have been detected in the environment worldwide. Next, please. The presence of pharmaceuticals in water has raised serious concerns because even at very low levels, certain pharmaceuticals have been proven to cause undesired adverse effects, as was mentioned by the previous speaker, on ecosystems, including mortality, as well as change to physiology, then behavior and reproduction. For example, oral contraceptives have caused the feminization of fish and amphibians, and the overuse and discharge of antibiotics to water bodies intensifies the problems of antimicrobial resistance. Next, please. So my research group focuses on different technologies for pharmaceuticals removal from water using different bio and nanomaterials. For example, here on this slide, I have presented that we study advanced oxidation processes where we investigate different nanomaterials and nanocomposites. We also study adsorption process using different materials such as biochar, carbon-based adsorbents, mineral-based adsorbents, nanocellulose, and clays. So the main focus is that how we can develop biomaterials which could also work as nanomaterials or bio-nanocomposites. Although I was asked to deliver my presentation on photocatalytic treatment of pharmaceuticals in water, so I will focus only on this topic and present the results of a recent study in my talk today. Next, please. Right. So you already got some idea about advanced oxidation processes from the previous speaker. So I will a little bit elaborate further. So advanced oxidation processes are used to increase the efficiency attained by conventional physiochemical and biological treatments and fulfill the crucial limits fixed by various environmental regulations to deal with persistent pollutants, which are present at microgram per liter level in water. So advanced oxidation processes are the oxidation processes which generate hydroxyl radicals in sufficient quantity to affect water treatment at ambient temperature and pressure. Finally, the toxic organic pollutants are degraded into carbon dioxide, water, and mineral ions, which are harmless. Next, please. So when we talk about advanced oxidation processes and in particular photocatalysis, it is always a great challenge to find and design efficient photocatalyst for use in photocatalytic degradation of organic pollutants. I would like to here mention a recent study where we have developed tungsten oxide for different pharmaceuticals removal from water, which has a smaller band gap than other widely used photocatalysts such as titanium dioxide and zinc oxide. Next, please. So I would like to briefly present the main findings of this study, where we investigated the photocatalytic degradation of pharmaceuticals from water using nitrogen-doped magnetic tungsten oxide embedded in mesoporous carbon. Next, please. Now I will briefly present how this study was conducted. So on this slide, you can see a schematic illustration of the synthesis of photocatalyst. And I will briefly explain how this was prepared, this was synthesized. So the organic materials covering the cell wall of diatoms. Diatoms are natural microorganisms which are present in water. So we remove the organic material from the diatom cell walls using sonofenton process to prepare nanoporous silica. Then iron oxide nanoparticles were immobilized into clean frustule to obtain magnetic frustule. And these frustules are the outer layer of diatoms, which contains silica. Later, carbon and tungsten oxide precursors were adsorbed onto the obtained magnetic frustules. And finally, the nitrogen doping of the obtained material was done using a plasma reactor under nitrogen atmosphere. By this way, we obtained nitrogen-doped magnetic photocatalyst having tungsten oxide embedded in mesoporous carbon. So the process looks a little bit complicated, although the process was simple. And the main idea to prepare or to follow different steps was that we could enhance the photocatalytic degradation of the antibiotics. Next, please. So in this study, 3 beta-lactam antibiotics, namely cephalexin, cefazolin, and cephadine were studied, as these are used to treat infections caused by gram-positive and gram-negative microorganisms, which can reach aquatic system due to improper disposal or inefficient water treatment, thus representing a risk to the environment. Next, please. Yes, now I will briefly present the results of this study. So the material was fully characterized using various analytical techniques. And you can see here, we did XRD, SEM, EDS, TEM, BET, Raman, XPS, etc. Next, please. So the idea was, why we did this characterization, because the idea was that we can get an insight of the properties of the material. So because of the limited time, I cannot discuss the characterization results here, but you can find all details of our published article. After characterization, photocatalytic degradation of 3 selected antibiotics was investigated, and results are presented here on this slide. So you can see here already that the control test revealed that the absorption of antibiotics on the developed photocatalyst in the dark was insignificant. Moreover, only visible light irradiation had a negligible role on the degradation of antibiotics. The best degradation results were achieved by nitrogen-doped magnetic photocatalyst, which can be attributed to different reasons. For example, number 1, easier active species formation due to the narrower band gap and effective visible light harvesting. Number 2, spatial mesoporous structure and crystallinity with the high surface area for proper transportation of reactant to the catalyst sites. And number 3, appropriate separation of photo-generated electron hole pairs owing to the above mentioned synergistic effects. Next, please. And here we identified the pathways that how the pharmaceuticals, they are degraded. So on this slide, you can see the plausible pathways for the degradation of antibiotics. And it was detected that the antibiotics were degraded into inorganic ions, carbon dioxide, and water, showing the complete mineralization of the antibiotics. Next, please.
You've got 1 more minute, Amit.
Right. I will finish.
Great.
Yes. So based on this study, we can draw few conclusions very shortly. So nitrogen doped magnetic photocatalyst had larger surface area, narrower band gap, more visible light harvesting, and confined electron hole pairs recombination. And what we found is that more than 90% of antibiotics degradation and 76% of total organic carbon elimination was obtained in this study using the visible light irradiation. Next, please. So the details of this work could be found already in our published article, which was presented on the previous slide. And to conclude my talk, I would like to mention here these two important papers published in Environmental Science and Technology, which have discussed the importance and shortcomings of photocatalysis in water treatment. Despite many benefits, there are several challenges in this technology, which limits its practical application. Therefore, robust catalysts are needed that can sustain repeated use and enable low-cost recovery from effluent streams, and material science could play an important role in this particular case. Moreover, the need for elegant systems design is currently greater than the need for catalysts with greater hydroxyl radical yields. So we have published our articles on the topic, and if you are interested, you can please refer our articles. And since this workshop is about collaboration, and as you all know that collaboration is a key for success, so I am looking forward for the potential collaboration with all of you, especially for forthcoming Horizon Europe calls, Water JTI calls, and other funding calls, where my research group could offer complementary expertise and could bring value to the consortium. Thank you very much, and feel free to contact me by email to discuss collaboration opportunities. Thank you very much.
Excellent, thank you, Amit. I know we ask a lot of all our speakers, both you and Lucia, squeezing short slots, but inspirational insights. I've got one question on the chat. Did you conduct experiments? As my
Yes.
Screens pop up with real wastewater matrix? You can see it perhaps yourself on the chat.
Right.
Could you answer that?
Yes. So basically, we have the results which I presented here. And these experiments were conducted with not with the real wastewater. And now we are in contact with some pharmaceutical companies where we will obtain the real wastewater, and the study will be continued to check the potential of this catalyst with real wastewater also.
Okay, good. If others have got questions, use the chat and we'll catch up a bit later. But I was pleased to see Amit on your last slide, and I think it's also part of the sort of DNA of WETSUS, the extended invitation for cooperation with other regions and their SMEs and obviously their research and innovation partners. Right. And I think that's I was going to ask you that question, but you gave me in your presentation, so spot on. I think that's an important message to share.
Thank you very much, Mark.
Well, thank you again. So now we're going to move on to our next working group, and it's the same format. So you've been warmed up, and thanks for Peter for doing that, setting the standard. Daniel Isidora is going to give us some oversight on the issues, and he's representing Agri-Food Research and Technology Center from Aragon. And then we'll have two more detailed presentations that will follow up. But Daniel, over to you.
Good morning. I will just say a couple of words to introduce my colleagues about the status of the Working Group 2. So next slide, please. As Mark has said, I am Daniel Isidoro from Aragon in Spain. The Working Group 2, so far we have included 33 participants from 6 regions, and we have held 3 meetings. In the last one, we are focusing in preparing or thinking of preparing a contribution or a project for the next Horizon Europe call. So next slide, please. Just to tell you that among the 33 participants, we have introduced a very wide band of possible actions, of possible interests of research, and we are trying to concrete something in which we take into account most of the interests of the working groups, including basically the most mentioned ones were addressing other pollutants, addressing filtration techniques, addressing the production of biogas, addressing the particular case of cattle production, and using microalgae. There are very strong groups working on most of these points in our consortium. Next slide, please. And then in order to see what we can agree to do for the next Horizon Europe call, we have sent this template to our colleagues, where we have tried to synthesize one, two, even more, but especially one project, one research interest in which each group would like to participate. So we are asking to give some information, brief information about the contact of the organization, then what type of research we are interested in doing, in what subcall of the cluster 6 or others we would like to apply for, and what are our suggested lines to work, what facilities do we have available, or what procedures we have already developed, and then what partners do we need, what other not research but other stakeholders we are in contact with that we can include in the project, and basically that is. So we are waiting. We have received already several of these templates, but we are waiting to have more of them in order to decide where to head in our proposal for the Horizon Europe call or not. And then you can proceed to the next slide, please. Yes, to tell you that we are going to present two of our colleagues are going to present two already developed works. One dealing with the reduction of ammonia emissions to the atmosphere using peak slurry for fertilization of crops, and the other one dealing in Finland with the production of biogas from wastewater, from agricultural return waters. And I have nothing else to say. If you have any questions, please feel free to address me. But I think the presentations by Eva and by Panu, sorry, will be much more interesting for you. Thank you.
Thank you. Eva Herrero, would you like now to take the floor? And
okay, thank you, Daniel and Mark, for the introduction. Well, I'm working in CITA with Daniel, which is a research center in Aragon that focuses its activity mainly in the agri-food sector. And although research occupies main part of our activities and time, we are also involved in the implementation of and coordination of demonstrative projects like the one I'm presenting now. So next slide, please. The Life Arimeda project, which we coordinate, focus on the nitrogen recycling of organic fertilizers and in reducing ammonia emissions linked to the application of these fertilizers. Ammonia emissions the reduction of ammonia emissions is one of the priorities for the European Environmental Agency, not only because of their environmental concerns, which I think they are all well known, but because it is also related to human health risk because it takes part in the production of fine particles that affect to human health. The sources of ammonia are very related to agricultural activities, and more specifically to more than half of the emissions are linked to the application of nitrogen fertilizers, either organic or inorganic. So this is where this project focuses its activity. So next slide, please. What Life Arimeda project intends to do is to tune in and demonstrate that fertigation techniques can be applied with the liquid fraction of pig slurry and digestate in order to inject this source of nitrogen in irrigation systems in areas where extensive crops are widespread. What the two main targets of the project is the reduction of ammonia emissions without increasing the risk of leaching, of nitrate leaching, and the promotion of nitrogen reuse in Mediterranean agriculture. How we approach this subject is, well, trying to replace the nitrogen supply during the whole crop cycle with organic sources, replacing the synthetic fertilizers, and minimizing losses either to air with ammonia emissions or avoiding nitrate leaching. In this type of projects, we work with other research centers, with farmer associations, and with private companies. So it's a clear example of how our network with other type of entities is working. And next slide, please. We implement the fertigation techniques trying to reduce the ammonia emissions and improving the nitrogen use efficiency based on 4 main ideas. To lower the ammonia concentration in the liquid, injecting the liquid fraction directly in the irrigation systems, applying the nitrogen dose according to crop demands in time and in quantity, splitting the nitrogen applications to the crops in several events instead of doing it all together in 1 or 2 events as it is done traditionally by farmers. And sorry, but I cannot see the slide very clear, but trying to implement in the fertigation with irrigation systems that are that let reduce as much as possible the ammonia emissions. Next slide, please. In this type of European projects, we are working with other regions, in this case with Lombardy. We are working in 4 different sites in large-scale demonstration plots. We are implementing these techniques in plots like, that are around 10 hectares, so it's not a research activity. And we are evaluating these techniques, comparing the traditional fertigation practices with the fertigation practices in pivot and drip irrigation systems. Next slide, please. Just to give you an idea of the type of activities that are involved in the project, here I explain you in 3 steps how we have performed the fertigation in these areas. The first step was to remove the large particles from pig slurry. For that activities, all the private companies involved in the project have developed and designed separation prototypes that provide the liquid fraction appropriate for injecting this liquid in the irrigation systems. The second step was to organize all the logistic and all the transport from the farms to the plots. In this step, all the farm associations involved in the project have cooperated and contribute organizing all these logistic activities. Next slide, please. And the last step was just controlling and the nitrogen application in the plots and installing, adapting the irrigation systems in where the fertigation was implemented. There you can see some pictures. As you can see, we have just installed a small storage close to the plots. The injections in the injection systems just have a pump to inject the liquid fraction and some filter systems to control to avoid any clogging problems. Next step, please. Next slide, please. During the whole irrigation season, we have controlled ammonia emissions in the plots using these bad samplers you can see in the picture, and we have also controlled the risk of nitrate leaching. have not measured the water flows, but we have just compared the nitrate concentration in water below root zone in reference plots managed with traditional practices and fertigated plots. Next slide, please. We have also evaluated the agronomic performance of this technique, because in the end, if you want to transfer this kind of research or works, you need to demonstrate to farmers that these techniques provide some profit, not only environmentally, but also in the economic balance of the farming system. Next slide, please.
Got one more minute, Eva, please.
Yeah.
Thanks.
Just for concluding, I want to highlight that the results that we have obtained from 3 years of trials is that we have realized that we are able to reduce more than 60% ammonia emissions and more than 85% ammonia emissions in the different irrigation systems. We were able to improve the use of nitrogen from the crops, and we were able to replace the use of synthetic fertilizer during the whole crop cycles. Next slide, please. We also evaluate not only the environmental and agronomic performance, but also the suitability of the technique technically and economically. We invite you to check the final results in a few months that will be available in the website and in the social media of the project web of the Life Arimeda project. And just the next slide, please. We invite you to check all the information that we have uploaded in this media, because I think that can give you a clearer idea of what we have done and all the activities we have performed.
Excellent.
So thank you for your attention.
Thank you very much, Eva. Perfect timing, and a good illustration of an interesting and perhaps underutilized European program called LIFE, which I think you gave a good showcase there. There are some questions coming in, so we'll pick them up at the end when we've had our next presentation. So have a look at them, Eva, and then you'll be ready and to answer. So the second presentation on this working group, we're going to look at the biogas plants approach from manure and other agricultural science streams from the Mikkeli region, and it's our Finnish partner, Panu Yukimo, who's going to tell us a bit about the experiences on this particular issue, which I think is very relevant to the Green Deal agenda. Panu, your 10 minutes of fame starts now.
Okay, hello everybody. I'm Panu Jouhkimo from Mikkeli Development Company, and I represent the Blue Economy Mikkeli cluster, and I just want to showcase a few case examples of biogas plants utilizing or integrated in the agri-food sector or food production. So let's start. Next slide, please. Next one, please. So Mikkeli, we're located in the eastern Finland, 2.5 hours from Helsinki, and in the next slide, please. Yeah, we are a small town, 55,000 residents. So next slide. We have, for this size of city, we already have 3 biogas plants in the region. 2 of those, Juvan Bioson Ltd and Biohauke Ltd, they are using feedstock from agriculture side streams, and the third one, Biosairila Ltd, is located with the local waste management center, and they use wastewater sludge and bio-waste. And we have 3 biogas filling stations in the region. So the main 2 of those biogas plants, they produce biomethane for vehicle use. So, and we have 3 filling stations. And the filling stations are operated by the city-owned energy company, ESE Ltd. And one more filling station will be commissioned actually in June next month. And there's also an option for it'll be like a satellite station for LNG. And maybe the LNG, let's see how it goes, but it can be sold as a renewable biogas but that's still under process. So both biogas and natural gas is available. And all of these biogas plants, the digestate is utilized in the region in different forms in agriculture or soil enhancing in other locations. Next slide, please. Last slide, please. So first, if I go through the first biogas plant was commissioned in 2011. It's owned by the farmers, and the idea is to utilize the cow manure and the chicken manure and agricultural side streams evenly, the nutrients evenly in the fields. Some of the farmers produce more nutrients than the others, and the other farmers they need more nutrients than the other. And when the biomasses are processed in the biogas plants, the biomass is then what's the word? Sorry. Now I lost the word, but let's go on. It enables that the digestate can be utilized as a soil enhancer, and the biogas plant is a wet digestion unit, and it's built by a local company, Metener Ltd. Next slide. And here's a picture of the Juva biogas plant. Next slide, please. Then the Biohauki Ltd. It was commissioned in 2017, and it is also owned by local farmers, but there's also the local energy company involved owning the biogas plant. And here the main product is of course the fertilizers and soil enhancers, but the vehicle fuel, and they produce 700,000 kilograms of biomethane per year. Next slide. And the feedstock, it comes from the cooperative farms. If I remember correctly, there are 10 farmers owning the co-owning the biogas plant. The feeds in the process are cow manure, dry and wet. So they are both. There are milk dairy farms and beef stock farms, organic beef stock farms. They are chicken manure and then plant-based biomass. There are two bigger organic open field vegetable farming companies or farms producing plant-based side streams, so to say. And here the same idea that some of the farmers produce more manure than or nutrients than they can apply, and the vegetable farms, they need the nutrients so they can even out the load. So, and the maximum capacity is 8,000 tons per year, and they have 2 reactors. Next slide, please. Yeah, 2 reactors. It's a mesophilic plant, and it's ongoing dry fermentation process. So it's relatively dry stuff. 21 to 23% of dry matter. Retention time is approximately 30 days. The plant is located or connected to the local heat network. So when there's alternative use for the energy, but the main product is the vehicle fuel. And with the current feedstock, yeah, the potential production is 300,000 cubic meters of raw biogas per year. And here also the digestate is separated into two fractions: the dry fraction, the solid fraction, and the liquid fraction. And it will be delivered back to the farms as organic fertilizers. There's also a network of satellite reservoirs for the liquid fraction, where then the liquid fraction is spread to the fields.
I know you've got 1 more minute now.
Okay, let's go further on. I think there are photographs of the site. Common worries and solutions: odor emissions, sewage water, noise, they are tackled. Air emissions. Next slide, please. And here's about benefits about the use of the digestate. So the total ratio doesn't change, but the nitrogen becomes more soluble, and the liquid fraction and the solid fraction have different ratios of the nutrients. Next slide, please. And here's about the benefits for the vehicle uses of vehicle fuels. I can say that we're really happy. There are 4 biogas buses started operating this month in Mikkeli. So now we have buses using cow manure as a fuel. So next slide, please. And here's the aerial picture. So it's located by the local Kyyvesi, local lake, and maybe the most beautiful biogas site in the world. I don't know. Next slide, please.
I think we are at the end of your time slots, Panu.
Okay, I think I'm done. Yeah.
Okay. Thank you.
Thanks, Panu. While you're on the screen still, there's one question that came in from Marisa. She was interested about the relationship with the farmers and their sort of economic benefits. What do they get from transforming the manure into energy? How has that worked for them?
Both in Juva Bioson and Biohauki, they are both organic farmers and regular farmers, but the main benefit or the main motivation has been the nutrient value of the that they can apply the nutrients.
So they get the byproducts back.
Yeah, and for example, in Biohauki case, the business model is built so that the company is owned by the farmers and the energy company, and then there's this cooperative that organizes the logistics of the manure and the fermentate, and the company doesn't take any fees for accepting the manure neither doesn't acquire any. So there's no monetary interaction.
Okay.
So they just borrow the manure for the biogas production.
I guess they are getting their manure removed for them.
Yeah.
Okay.
They just loan it for 30 days and then get it back. And the logistics, of course, is a big thing. And one of the only solution was the dry, because the logistics, it's the transporting of the liquid fraction is expensive. So that's why they
dry it on the farms first.
Yeah. No, chose the solid kind of a dry fermentation process though. So there's as less water involved as possible.
Okay, thanks for that, Panu. On the chat, we've got a couple of questions for Eva from your presentation earlier. Just take a few minutes to answer them before I don't want to deprive everybody from their full coffee break, but I will shrink the coffee break because I want to come back at 11:40. Question from Peter de Jong. I don't know if you had a chance to read it, Eva, or do you want me to read it?
Yeah.
Okay, so what's the answer to Peter's question about the growth season of crops? What happens in the non-growing period?
Sorry, no, I haven't read this one.
Oh, sorry. Well, which one did you read? Then you answer that one, and then so you want.
Okay.
The two questions.
This within the growth season, but
yes.
What do you do in the non-growth season? I just will then flush quickly to the ground. Okay. We monitor the nitrate concentration below the root zone since the beginning of the fertilization season till October, November, which is the time for harvest. We haven't measured the leaching, as I have said. We just have compared the nitrate concentrations in the nearby in plots managed as farmers usually do. And we have compared this concentration once a week with the concentration that we get in the fertigated plots. What we have found is that concentrations were more or less quite similar or even higher in the traditional plots, because nitrogen is concentrated mainly in two events. First one with pig slurry at the beginning of the season before sowing, and another event when maize, because we have worked mainly with maize in June. And in our case, as we are splitting lower doses through the growth cycle of the maize, we are not providing so much nitrogen supply altogether. And then the concentrations that we have measured were in the same level. We haven't found an increase in the risk of this leaching.
Okay, thanks. The question that you were going to perhaps answer, the involvement of farmers in the project?
Yeah, there were two farmers associations directly involved in the project, one in Spain and the other one in Lombardy. And they participate in the project from one side managing the plots, because as I have explained, they were productive plots that belongs to farmers, and they expected to have a regular economic benefit. And the other side, the farmer associations have take part in the transference of the knowledge. We have organized a lot of transference activities, and they were like the nexus with the sector to transfer all and receive their feedback.
Okay. On the more generic question that Amit asks regarding challenges, I suggest you put some points down in the chat, and then we can come back to that a bit later, because I want to make sure everyone has their comfort break, their cup of coffee or tea. So I suggest we stop this Q&A session. We have another one at the end. So now we have I think maybe a slide will show us that we have a coffee break. And so I can say thanks to Panu for giving some responses on the chat as well. So that's good don't hesitate to answer the speakers via the chat as well. And it says it on the slide, 11:40. So make your coffees, teas, fresh air. And 11:40, when we'll have Hanu will be there. So don't miss him. 11:40. See you soon. 1 minute. So time to get your hide your screens again, or your headsets, in my case. Okay, it's 11:40. Oriane, I hope you're with us. Yes, because the slides have moved. So we're now looking into the third working group. You've got the routine now. And this one is looking at the issues of digitalization. Digitalization, as we know, is one of the three mantras from the European Commission at the moment. You know, we hear a lot about green, we hear a lot about resilience, but underlying many of those factors to succeed in both the green and the ecological transitions is the digital dimension. So we've got two presentations here to shed some light on the work of the working group on digitalization. And our first speaker is Hannu Nikurajo, Senior Director at Uros Limited. So Hannu, the floor is yours. We'll give you the usual 1 minute warning. So good luck.
Okay, thank you very much. So my name is Hannu Nikurajo, and in the Uros, I'm business owner for two of the IoT solution what is related to water, and that's the theme what we talk about it today. Hey, I propose that we jump directly to slide number 4 for time saving. One more is if you go one here. So before to go into the solution and those innovation what we have done in this area, and then also to talking them through, I want to start at the angle what is the obvious to some people in here, that if you look the water overall, it is coming to be really critical in the globally. So availability, quality of the water, and how to then bring the technologies and innovation in this area so that we can avoid the leakages, we can improve the water quality, and then also to go into the direction that we can predict early, so that this kind of incident then is not going to happen. If you go to the next slide, thank you. So looking this challenging area, so when we bring the technologies from today and even the good innovation here, we are really touching the point that we can improve the health and influence the health assurance, but also to protect the environment. Plus then it's the question of the cost saving too. So if we go to next slides, so from that angle, we have provided now in the two different kind of service. One we call it the flow, and that's for the water management, and then other one is called it the sense, what is the water, or then any liquid quality monitoring. I want to go through this Uros sense first. So if we go to next slides. So the Uros sense is a combination of the this kind of the cloudified service where we have an AI algorithm running, and all the brain is there. And then we have a unique design by ourselves to the sensor itself. It is the plug and play sensor. It's not needing any of the power wires. It's the connectivity is arranged. So it is easy to install, fast to install, and it will be connected directly to the service, and then it's ready to go. Sensor head is the main thing in there. So it's kind of the patented design with the different kind of metals, where we have then redox-based measurement, what is quite familiar in the industry in some sense. This one, if you look the liquid monitoring there, so We can go actually in the next page. That is a bit of the animation, so bear with me in here. So this is the showing now the water resourcing overall, and then this kind of safety plans, sanitation and water side. So with the monitoring the different points, you can then improve the understanding whether about the water quality, what is the coming the water treatment production, what is then happening in industrial. Today, it is also the question about in industrial that how well we can recycle the water, what they are using the processes, and this way improving the cost and bringing the cost saving, plus then looking at what we are actually then leaving in the nature. So that's also then when we go to wastewater treatment plant side. So if you click now the ones, you can see the example about installation the river side. So we can bring it easily in the, if you go further with clicking, so you can then see that also it's easy to bring in the, for instance, water production. And if you can click again, so then it's the inside of the industrial and different kind of setup there. And the last one, if you click, is then coming to the wastewater side. That it depends how you want to install those in there. So that's the basically the shortly the UROS sense, and this is the area where we do actually a lot of cooperation with the universities, and then also with ecosystem in nearby of our company, to even to improving the understanding that how to improve the understanding of the behaving of the liquid by taking the fingerprints, and then understanding that what kind of the events has happened and how we can prevent those, how we can pre-warn early enough that this kind of things might happen and or has happened early, and what we need to do in that sense. So we kind of to prevent earlier warn them to customer that how to do the next action, so they don't need to stop process, or then clean water is not then in the situation that it can harm something for the consumers. So let's go to the next one. So then I will go briefly through also the other one. So this is then the kind of the water management, and can be then also utilized in the wastewater side. So it is the looking that the main function is to find the leakages in the network, and then at the same time we can show the pressure flow and spread of the water. We started here the digitalizing first the whole network. So many times we have a situation that there's no any digitalization. We digitalize that, we take a data from the network, we utilize the data, making the schema there and starting to measure it. And this way also the understanding behaving of the whole water network. And based on this also started to do the forecasting that where we should put it, the investment, where the customer need to go to do the next moves in the network, so that it's the really then focused investment, plus then we can prevent any of the harmful leakages coming. So that's the basic idea. In the user interface, we have also come in the today's model from the traditional, so that we are basically showing only the things what is needed to show. So nothing too many numbers, etc., but we visualized when we need to do something and what is happening there. So let's go to next slide. So here's one of the example of our work that typically the leakages can vary. So like in the India or Brazil, they might have a 60% leakages and non-revenue water there. So we have a targeted always with customer where we want to end it up year by year. And this is the one of the Finland example where we have managed to come from the 30 to close to 10% leakages. Leakages will be always in the network, unfortunately, for some point. Let's go to next one. Yeah. So these are the two innovations, and they are now in place. And we, as I said, we have a lot of cooperation with universities, ecosystem players, and we are rather more than, we are really interested all the time to bring more players to how to improve this area, how to come to real, not only real time, but improving the forecasting, bring the AI algorithm, cooperate together, like we have a cooperation with SenseMed so that we can improve, for instance, in the mining, to everything together. So that's the something where we are more than interested than and I personally interested to discuss even later on. If you go to the last, my slide. So I want to stop here so that it's like a smart city is coming from the many angle, and how we can help them to coming to smarter city. And then usually so that if you do this smarter way, your city will be more competitive, safe, and liable. So that's my part today. Thank you for listening, and I hope to have a cooperation later on even.
Excellent. Thank you, Hannu. Perfect timing. So some questions are coming in on the chat before we go to the next speaker. When you're using the chat, can I ask you to use the category panelists and participants? Many of you using just to the panelists, so it's nice for the if you want to do that, fine, but if we want everybody to get the answers, so when Hannu, when you reply to Salome, or you do it by camera later, remember, use the heading panelists and participants. Okay, for the next presentation under our digitalization group, we've got a double header, Laurence Courcy and Nicolas Surdic from BRGM in France. So Laurence, I think you're going to start, and Nicolas is there to support. So the floor is yours.
Yes, thank you very much. So I will present you the result of a study that were applied in many places in France with quite success. So we developed it in the French Geological Survey, and my colleagues Nicolas is more involved, but I will make the presentation. So the idea is to work with nitrates. So why nitrates? Next one, please. It's because, of course, it's one of the major problems still in Europe. For causing a good status, for example, for feeding the quality of the groundwater. And additional difficulties in the next slide, please. Yeah, so there was two things that are difficult, that make it difficult to link the pressure to the impact. Is first the water level variations. You see in the left part that the concentration of nitrate in groundwater moved from 20 milligram per liter to 60, but it's absolutely not because of variability of pressure, but it's just for water levels. So this has to be taken into account. And the second problem is a time lag. So in the right part of the graph, you see in blue the pressure, that is the excess of nitrogen below root zone. So the pressure decrease from 1984, but then you see that the concentration in groundwater still increased and started to decrease more than 10 years after because of transit time of the water and nitrate from soil to groundwater. Next one. So the question we try to reply, and we can reply with this coupled approach I will show you now. It's which measure should I take in order to decrease the concentration of nitrate in groundwater? The measure taken would be sufficient to reach the good status, when I will reach this good status, and at which cost. So next. Yeah, so we have two tools. So one is the modeling, nitrate modeling, and the second one is the economical evaluation. So from nitrate modeling, we estimate the waste and transfer time of nitrate from soil to aquifer. And we evaluate which agricultural practices may lead to a decrease of nitrate, and also the evaluation of when the threshold values will be reached. And the economical evaluation is to make the cost efficiency and cost benefit evaluation in the same times, being back and forth with modeling and having exchange during workshops with the stakeholders and the agriculture world. Next one. So the modeling of nitrate, there was many ways to model it, but the idea here is to have something quite simple. So we can use the tool even during some meetings. So it can be really updated quite quickly and propose the evaluation should be made rapidly. If you need a big modeling system, when you take 2 years first just for the modeling, then you have maybe not reached your objectives. So this models is coupling climate, so hydrology, with land use at safeguard zone, small watershed or sampling points, like drinking water abstraction wells, for example. So you have 2 different models that are combined in one. It's in a global modeling systems, where you have then in one part hydrological simulation and the other part the nitrate concentration simulation. Next. So the cost benefits efficiency analysis consists, of course, I evaluate all the cost of what you could do. So you can conserve your system in a safe way. If you don't do it, maybe you will need in one moment to make some curative actions, like make a treatment, water treatment in order to distribute your water. You can also want to recover your system because then you want to go back to the good status. And you can also do the laissez-faire. That means that you leave other activities, installing it around your drinking water abstraction wells, for example, and then you see what happened. Usually it's not good. What would happen will not be so good. So for each of these activity you have to do, or you try to do, or you wish to do, you have, of course, associated cost. So you evaluate all these costs, and then you can show what would be the advantage of conservation of your system, or maybe not, or maybe you prefer do the laissez-faire or whatever. So this is the economical evaluations. Next one. So I will show you in a concrete examples here. So the case studies, first, of course, you have to build your model. So here you can see the concentration of nitrate in your well. So you see that you are not in good states because you have more than 50 milligrams per liter of nitrate. So you have to do something. And in the same times, you start to prepare some scenarios with the stakeholders. So you can make this economical evaluation in the same time you're running your model. Next slide, please. So here you can test different scenarios. So there you can see the laissez-faire, so you don't do anything. So you see that today's actions are quite enough to decrease the concentration of nitrate, but of course they are absolutely not enough to reach the good status. So the decrease is very slow. So you have to do something else in this catchment. Next slide. So then together with the stakeholders, going back and forth with models and economical evaluation, you test different scenarios. So you put some more sunflowers, some alfalfa, you change your fertilization systems, whatever, and you calculate in the same times for each of these scenarios, what will be the cost. Here you can see the variability of the annual profits. So negative is because you are losing some profits. So some scenarios are, of course, not acceptable for economical point of view, even they are quite good for the ecology. So then you have to choose the correct one, which is not so much lost, and then you can reach a good status. Next slide. So here you have the concrete case studies. So at the beginning, of course, you have the first points here in 1980, when you are building your drinking water abstraction wells. You see that immediately you have a great increase on nitrate. Nothing happened, nobody take actions. So then you start to reach you go over a limit of concentration that is not acceptable. So then you have to take some actions. So here you have different type of actions. Some are curative actions, like data treatment for nitrate before distribution of the water. And you can also take some recovery action, putting some grass over your drinking, your abstraction wells, for example. But all these are not enough. So then you have, we had all these projects and we reached to some actions that are economically acceptable. And then they can lead to a large decrease in nitrate concentration, like you can see here. This is that you put double superficies in alfalfa. And then once you have reached this 50 milligram per liter or a little bit more, you have to be sure that you preserve this situation. So you should not, again, put some different actions that can lead to the decrease of the quality of water. So next slide. So this project, it's then a back and forth between modeling and cost benefits analysis. You have also the possibility to take into account the climate change in the models and in the economical analysis. So the idea is to have a quite simple modeling tool, fast to implement and allowing to test various scenarios. The effect of measures on groundwater resource quality could be evaluated during seminar exchanges with stakeholders. And the idea now is to see whether it could work in other countries, whether we could improve and what could be done to improve it, making different type of modelings or different approach, economical approach. So this is opening for collaboration with European countries in the future. Thank you very much.
Thank you. Merci, Laurence. I don't know if Nicolas wants to add anything to the conclusions. If not, we can go to the Q&A.
It should be okay.
Good. Thank you, Nicolas, for being with us. So we've seen some feedback on the chat. Just following up on what Laurence, you just said in your last slide, to what extent does BRGM cooperate with SMEs? For example, in the case studies you've just presented, what's your sort of policy on SME cooperation, both within France and internationally?
Yeah, so this is a question for Nicolas, I think.
Mm-hmm. Oh, well, Nicolas, question for you.
What do you mean by SME?
PME. To what extent does BGRM cooperate in the examples we've just had from Laurence with PME?
In fact, it's very important because when she, in the exact example, she shows that the best example was to add as much as possible alpha-Ga, but we have to build all the industrial chain of alpha-Ga. It just propose this to add grass. We have to build then a dryer for the alpha-Ga and then a logistic chain. So now we have to find a SME, dry this alpha-Ga, and then the logistic. So it's not only to propose the because if they cannot sell, because if this catchment is not almost no dairy farm, they don't have an output for this alpha-Ga. So now we have to find SME for a dryer, a logistic to sell, and so on. So
the answer is yes. Yeah, they're involved. SMEs are involved in your projects.
Yes.
Okay.
So not now, but now we have to find for the next step.
Good. Well, this is the, Winning Days is the platform. And to what extent, on a more general level, the BGRM deal with Horizon 2020, which now is going to be Horizon Europe. Are you heavily involved in collaborative research?
Yes. We have various projects. I mean, in the BRGM, in the French Geological Survey, we have a large panel of activities. So on agriculture, we work on diffuse pollution, of course, on this aspect of trying to improve the quality. But we also work on emerging compounds and many activities. We also are part of this GeoRERA project. That is the combination of all geological surveys, trying also to put our knowledge on the groundwater functionings to any activities that are on the surface.
Okay, good. Well, that's another invitation to our Water Smart Territories partners. On the chat, thank you, Laurence and Nicolas, for those answers. On the chat, Hanu, you responded to a question relating to the different abilities of the technologies that you are deploying, their capacity to measure and test different compounds. And I think do you want to say anything a bit more about that on the detection abilities?
Right. So yeah, thank you for the question. That was good one. Typically asked also. So right now we have, like I put it in the chat, we have detected several of the compounds. The principle is that when we have this kind of fingerprint of the situation, what is the like, if you want to say good situation, and then if there's any change in the liquid, so if there's the change in the compound, that will be then seen immediately. So the question what was there, I think that we answer is yes, we can. And then if you don't directly have a experience of the sum of the compounds, we typically do the quick pilot with the customer, and then this way be able to so that it's we are capable to detect it that. So maybe that's the short answer now.
Yeah. Okay. And a similar question to the one I just posed to Laurence and Nicolas is and you said this on your last slide, the cooperation invitation. Do you currently have any cooperation partners from outside of Finland?
Outside of Finland, we have some of the cooperation on the radar now in the Brazil, but the main of the cooperation currently they are in Finland, in several different cities in Finland. We are looking forward always that if we have a chance to cooperate with universities, depending if we have a customer case, for instance, in the Brazil, so or then we use the ecosystem in the flow case. This water management system we utilize quite a lot in the local partners who has a water utility knowledge, and this kind of they can help us also to building up and digitalizing the network. So yes, we have already something in outside of the Finland too.
Okay, and I've got one last question before we move on to the next group session. The term smart cities, and in particular the sort of link to the utilities, obviously encompasses many other different themes, energy, air quality. To what extent do your clients, i.e. the municipalities, the cities, expect you as company X to participate in a broader strategy for ensuring the smart city agenda is implemented, or are they happy to see it dealt within, utility by utility, or in silos, water, energy, air, etc. So how does a city client, let's say, purchase? Do they regard you as a standalone product, or do they have a sort of a coordinated approach to the smart city strategy?
All right. So it depends, and I give a couple examples. So like in some countries, like lately in India, we have together with the government, they have selected our IoT solution for the whole country so that they can improve that is now in the water side starting point. They can improve the water quality, and then also they want to ensure that every household will get it the quality water in the rural even by end of 24. So we have this kind of broader discussion even the country level. Then in Finland now lately we have also had a cooperation discussion with the city, university, and some ecosystem players that how to utilize also this our flow solution, what is the managing the water network now in the energy side, so that we can start it also see the leakages in there. So that's because time to time also those companies who are dealing with the water management, they have also this kind of the energy side.
Exactly.
So we are now expanding but that's more now the researching that how we could utilize then this solution in there also. So that's kind of the starting point. now for that area.
Okay.
But it's clearly, like you say, that some cities, they are looking like a broader, and we try to also help in there as much we can.
Yeah, because I think at the European level, we've got this sort of circular cities and regions initiatives, and it's a whole ecosystem approach. And I think it's important for the sort of water partnership. We see it in the working groups. Digitalization is a transversal issue, so important to link up. Yes. Okay. Thanks for the feedback, Panu. Also, thank you to Panu for continuing to answer the questions on the chat. So don't hesitate to, request further information from our panelists. I'd like now to move to our final session 3, and we've got 2 elements. This week you're going to get really bored listening to me because I'm in the second part, so tough luck. But anyway, thanks for hanging on. But first, something much more interesting than me. Katrina Ulrich, she's going to tell us about collaboration opportunities with Blues Exchange. So Baltic Net Plasma Tech is a cluster. I know it well. So I'm very happy to give the floor to Katerina. Tell us about this Blues Exchange, and let's see, the mind boggles what could be behind this acronym. But over to you.
Okay, thank you so much, Mark, for the introduction. As you could see, I'm Katerina from Baltic Net Plasma Tech. We are a plasma technology cluster in the northeast of Germany, and we have a project together with the French water team and with Sinai, and with Water Alliance. We are in another project, so we know all the partners here actually. And yeah, I would like to start my presentation, which is very short, with a short video. So Oriane, can you just, yes, thanks. Yeah, thank you. So I hope you enjoyed a bit the video. I know that there was a lot of information just in this very short video, but as you will get all the presentations, so you will also have the link to see this again. So actually our Blues project is about exchanges, what was quite difficult in the last year, unfortunately. So we had a lot of virtual exchanges, but hopefully in September, October, we will start with the real exchanges. And this is actually your opportunity to step into this and to exchange with partners from abroad, to go there, to speak with them about R&D&I, about projects, capacity building, and so on. And as you can see, the exchange can be between SME scaling up support organizations and other clusters. So actually only excluded are large companies and universities, unfortunately. And the training activities and the exchanges between the partners are the main activities. But of course, as you could see in the video, there are many others. And as you could see as well, there is a budget for the travel and accommodation. Next slide, please. And these are the partners. So actually Blues is a blue and eco industry, as you could see in the first part of the video. So these are the partners, but as I said, even if you are from Water Alliance, for example, and you're a member of Water Alliance, you are an SME and you would like to go to another partner from another cluster. So this is always important that they have to be a member of a cluster. Then you can do the exchange. So yeah, just feel free to contact me, to contact any of the partners. So Oriane is also in the team, Marisa's in the team, Milen is in the team. So you can contact us all because we are all in the same project and we would really like to help you to find a very good new partner outside of your own region and outside of your own country. Next slide, please. And so, yeah, here are my contact details and thank you so much for your attention.
Perfect. Thank you very much, Katerina. Just two comments on this sort of cluster exchange. I think some of you may consider it an opportunity when developing, building a joint project. You know, it's a way of putting, you know, let's say, creating more in-depth relationships when you're working on a European project bid. So the timing with Horizon Europe is good. And equally, I think this the notion of peer learning, matchmaking, there's many different words we can use to describe what Katerina and her partners are supporting in this exchange project. And I think if you get a good sample of exchange at this level, you can look at other funding calls that support different type of matchmaking and peer learning. So it's a step towards a long-term cooperation. Okay, so this is the last part of the PowerPoint sessions, and I'm going to have to monitor my own time. So Oriane, don't hesitate to tell me to shut up when I go too long. So this last session is to try and build on what we've heard so far and say, okay, we've seen the different opportunities thematically, sectorally, you know, scientific and technology based. How can we fund some of these? How can we facilitate some of these? So just very briefly, we're going to give you a showcase of some of the key funding programs that have already been mentioned, but just to highlight some of their principal advantages. So we heard from Avelino Gonzalez from DG Research about the imminent launch of the calls on Horizon Europe. It should be early June, mid-June. It's currently consultation with the member states. The main characteristics of Horizon Europe collaborative funding are that it is collaborative, you know, where the European Commission is looking for partnerships, you know, minimum of 3 different countries. And depending on the nature of the funding instrument, you know, it can be more research actors, a mix of research and companies, or more companies and research. So as we move along the technology readiness level scale, the TRL, I think you're all familiar with that particular piece of jargon, you get very well 100% co-funding when you're dealing with pure research, and you get more like 50 to 60, 70% co-funding when you're getting closer to the market. We'll show you shortly some examples of the calls that are currently being proposed in the draft of the Horizon Europe Cluster 6. Second example, and we had a good explanation from Eva earlier on the program LIFE. Very well aligned with the water thematic, the water pollution, the water treatment dimension in both rural and urban locations. Smaller consortiums, that's a big difference between Horizon Europe, slightly smaller budgets, but it's slightly more open, and the thematics give you a chance to present your own project idea. Calls are likely to be launched in the autumn, September, October. The info days are going to take place in June, so it's something to watch out for. And I think in all of your cases, and when I say all, I'm referring to the clusters and the policymakers that lie behind the Water Smart Territories Partnership, they are in a good position to guide you. They've got information on their websites, and they organize regular briefing calls, and some have contracts to support SMEs present to the different calls. The sorry, my slide has just disappeared with the chat. The PRIMA program, which is mostly linked to the Mediterranean area, because you can see in its title, the Partnership for Research and Innovation in Mediterranean. So happens that GAC, we're working on a water-based project with Ceta Aqua based in Catalonia, Barcelona, looking at groundwater issues. So we know that the PRIMA works very well for the water dimension. It follows similar rules to Horizon 2020, consortium approach, etc. And most of the calls are funded under what we call a stage 1, stage 2 approach, which is good because it enables you to sell your idea in 10 pages, and then there's a shortlisting procedure, which then means if you get to stage 2, there are fewer consortium, there's less competition, and you've got a better chance because you've already been selected as having a good idea. So PRIMA, yeah, Mediterranean, so that's particularly interesting. Cooperation also, and I think the last one I'd like to highlight on this slide is the EIC Accelerator. Those who familiar with the SME instrument, it's very similar rules, but slightly refocused with the stage 1 SME instrument has now sort of disappeared. We have a 2-stage process where there's a template which, plus a video to produce. That's the new thing, and a quick turnaround to see if your stage 1 project has been accepted, and then you have literally 2 to 3 weeks to produce your stage 2, which is a business plan to demonstrate that you have a truly breakthrough technology with the potential for reshaping the value chain, and particularly important, the industrialization. And we have both investment and a co-investment dimension for this EIC Accelerator. And I think the new rules are a continuous continuous submission with fixed appraisal dates. So it's something it's worth looking at. Next slide, please. So with our friends in the partnership, we've highlighted a couple of calls that might be of interest, and just to maybe familiarize you with some of the jargon as well. So given that this thematic of our winning days today is zero pollution, we've looked at cluster 6. I think Avelino highlighted there are other clusters, but here we've looked at just a cluster 6. Just briefly, I'm not going to read all of this, you'll be grateful. But if you look at the first 2 as examples, so we're looking at regional nitrogen phosphorus load reduction approach with safe ecological boundaries. So it's a sort of a generic policy related, and that's why it's a CSA, which is a coordinated support action. So it's for research organizations, policymakers, supported by SMEs, but they're not necessarily in the lead. But it's a case of looking at trying to ensure, explore the different approaches across the challenges of regional nitrogen phosphorus load reduction. And often you'll see a budget indication and the number of projects. So it gives you an idea of how much funding per project. So it would be foolish to submit a project worth 3 million when you know they've only got 2 million and they want to support 3 projects. The research and innovation action, the second line down, clearly is more aligned with the research business company corporation nexus. And again, 2 projects will be funded. And this is where you have to demonstrate you have a European added value. You are going to improve the state of the art, and you have an impact and a business sustainability dimension to make sure the project has a long-term possibilities. And when you see the word, as we see on the right-hand column here, demonstrate, you know that you've got an opportunity to sort of engage with SMEs that are able to produce technologies or demonstration sites that can actually illustrate the question here, which is environmental performance. So the last one on this one is again about a CSA, an international EU sustainability certification in feedstocks. Next slide, please. These are again interesting calls from the perspective of the zero pollution thematic that we're looking at, and just maybe looking at the last one. It gives you an example. This is one big project with 12 million. So it's important that the consortia that is put together is a truly European. It includes federations, lobby bodies, but also has a strong SME and business perspective, because the demonstration dimension is to ensure that the viability of the solutions that are put forward are economically and socially acceptable to the communities that will need to implement them. So it's a good example of a sort of pan-European project. And the one above is again a 4 million budget, 3 projects, and looking at again farm level this decision-making process. And I think we saw from a number of your presentations, both Panu and Eva from memory, where farm cooperatives are involved. So it's perhaps an area for the sort of rural communities to work together. So that's just an insight, and I think Avelino said it clearly. There's many other opportunities, and I think working with your cluster partners, you will have the chance to review those. Quickly now to the next theme. This is something completely new, and I'll take 5 minutes on this. The Water Smart Territories partnership was sponsored by DG Regio and DG Grow as a means of accelerating value chain cooperation. So Francis and Marisa presented that at the beginning. Moving, let's say, further down the cooperation value chain, let's take this word, is the need to ensure some investment and support co-investment and interregional investment. So a new program will be launched later this year by DG Regio called I3. And the I3s, the I's relate to innovation, interregional innovation investment. What I say here is clearly current knowledge. It's a draft. We will see in probably June the call being launched, but it's an interesting step to let's say make cooperation easier, because there is some funding behind the initiatives that are being developed in the working groups. So this is where we really do need the SMEs and the working groups to come up with thematic value chain related projects that are aligned with the opportunities for commercialization and scaling up of your individual innovation projects at SMEs. Next slide. Again, you'll get the slides afterwards, but there are many strands in this particular project. Strand 1 and Strand 2, the difference is simply Strand 1 deals with more mature and technology advanced regions, and Strand 2 deals with less advanced regions. But the same principle applies, is that partnerships are going to try and bundle together a portfolio of projects linked to SME innovation and try and support them in different ways, connecting them to the research and innovation platforms and helping them either scale up the technology to a market level or actually take them to demonstration sites and make them support the value chain that is being developed by water smart territories. Next. Strand 1 will have, over the period of the program, almost 280 million. The first call will have a budget of 40 million, and they expect to support between 4 to 5 partnerships. So if you imagine within each of those partnerships, there's a portfolio of projects. In this case, they illustrate 2 to 10. So you can have some quite big projects. If you divide 40 by 5, you get an 8 million average, or if it's 4, it's 10 million. Or you have many smaller projects, 10 projects. So again, that's a sort of current framework. The selection criteria, 5 regions, countries. But what I think is particularly important for you to retain is the, and it's in the middle box on this slide, and I put it in between inverted commas, projects ideally to be led by S3 partnership regions. I think it's very important that it's not going to be easy for regions that haven't been working together to suddenly come up with a value chain concept and say, well, we can do this. So I think there's a good opportunity for the Water Smart Territories partnership in your SME ecosystem to consider this particular initiative. Again, high TRLs, it's clearly scale up demonstration. We're talking about TRL 6 to 9. Next slide. The type of investment, so SMEs, when you're looking at this and think, is it worth me jumping on board, working with my cluster in the Water Smart Territories? Keywords, I've used some of them already, but market uptake and commercialization, scale up, linking the type of expenditure to a productive investment. So it's demonstration plants, piloting, and there's even some contribution towards overhead, if we call it coordination costs. So the system that will be put in place is that the regional, the partner, the lead partner will receive money, and that will be distributed through a cascade funding mechanism. Some of you may have been familiar with this tool in other Horizon 2020 projects such as the INOSAP. But large part of the grant has to be redistributed to SMEs. As you can see, the final beneficiaries are companies / SMEs. Next slide. See, I'm almost to time. So we can use the remaining time to ask any questions, but we've got the next 10 minutes or so to allow Marisa to wrap up and for you to ask any questions to the last panelist, Katerina and myself. And I'm just looking if there's anything in the questions. Just to remind you, in the discussion chat, you'll see there's a satisfaction questionnaire that you can voice your opinion, and someone is saying they're having to go, so that's fine. So are there any other questions on the chat? Anyone who wants to from the Water Smart Territories, I think, because you've been working closely with the Commission, if you want to say anything on or respond to I3, now is the time, because I think you have a microphone. If not, we can let Marisa sum up the discussions.
Well, I guess it we don't have any other question, we can go on, Mark. Yeah.
Yeah. I think I just reiterate the point that a lot of information has been shared today with some familiar acronyms, some new acronyms, and I would urge you to use your cluster partners to help, particularly the SMEs, navigate through the minefield and find partners to respond to some of these new funding opportunities and technology development, scale up. I think the whole spectrum of opportunities is now broader than it has ever been, and we're at the beginning of Horizon Europe with a 2-year funding program, as Avelino said earlier today. So, Marisa, you have the honor to wrap up this second edition of the Winning Days. So over to you.
Okay, thank you very much, Mark. So just to conclude, we have seen today the complete picture of all the elements to contribute to zero pollution. No? We see the European Union framework, where all the water-related policy developments and objectives, how water smart territories answer to the zero pollution challenges through the 3 working groups, and also the funding opportunities. Not that also yes, we see really this explanation that Mark offered us. No? So how create this winning proposal to contribute to zero pollution? So first, if you have an interest in joining water smart territories, contact us. We are looking for the involvement of more stakeholders that contribute to the innovation ecosystem. If your region is already part of water smart territories, then it is easy. But if your region is not yet one of the actual 22, then contact us also, and we will explain how to involve your region. To be part of water smart territories, we need the regional commitment. Second, take advantages of the tools that the European Union, the European Commission offers to connect and build network. Take advantage of the Blues Exchange that Caterina introduced today. These are short-term exchanges to connect. And then these are tools that support you to build, collaborate, and innovative projects. And the European Union launched a new program to fund during this innovative proposal. So next slide, please, Oriane. Yes, and already has been said already. Water Alliance, France Water Team, and FINAE has been working together for a long time. So the Winning Days initiative, we want to boost even further cross-sectorial and cross-border collaboration, by bringing together all types of actors from Europe and beyond who are impacted by water challenges, and now know and work with each other. So yeah, we don't want to stop here, and Peter already mentioned, so we will have next winning actions in autumn. We actively, for this reason, encourage you to fill in a short questionnaire to easily get in touch with you and keep you informed about the next Winning Day actions, and also to improve ourselves the next editions. So your feedback is essential. Furthermore, as you already see in the chat, in the questionnaire, you also have access to the presentations of the session of today. Next slide, please. Just to conclude, my final word of this morning session will be for all the persons that have made this event feasible, especially to the speakers that provide a clear and valuable information. Especially also thanks to Mark Pattinson, who again brilliantly moderate this morning session. Again, a new winning session, Winning Days session that we are going to finish at time. And thank you very much, Mark. You know that now the Winning Day is already associated to you. Our team also that has made this event feasible, and of course, you all the participants and attendees this, that and that you are being very active in the chat, and thank you very much for this active participation. So take care and see you soon in the next Winning Day action. Thank you.
Thank you, Marisa. Have a good afternoon, everyone.